Hello everyone, welcome back. I hope everyone is doing great. My name is Raviteja. Let's solve today's Leetcode problem 1415, the kth lexicographical string of all happy strings of length n. Problem statement states a happy string is a string that consists only of letters of set A, B, C. Only these three characters are allowed. S of I is not equal to S of I plus 1 for all values of I from 1 till S dot length minus 1. The string is 1 based index. Okay. For example, the strings ABC, ACB and this particular string are happy strings and strings AA, and these are not happy strings. Okay. If you see at every index, the character is not equal to its next character. Okay, even here, right? Whereas here, if you see, the character at the first index is equal to the character at second index, so this is not an happy string, right? Given two integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. Return the kth string of this list or return an empty string if there are less than k happy strings of length n. Okay, let's look at this example. N is equal to 1. These are the strings which can be formed, right? These are the three happy strings which can be formed, and k is equal to 3, so we have to return C because this list is 1 based index. Okay, 1 2 3, so we have to return 3. Let's also look at this example. N is equal to 3. These are all valid happy strings and we have to return the string at the 9th position, and this is 1. Okay, if you see, let's take n is equal to 3. Okay, we have 3 positions available for us and we have a constraint that the character at I should be not equal to the character at I plus 1. Okay, so the first position we have 3 options, right? Either I can place A over here, I can place B over here, I can place C over here, right? Let's say I placed B, let's say I placed A. Okay, the next position I can only place B or C, right? I cannot place A. If I place A, then these two characters will be equal. Then this is not an happy string. Okay, so if it is A, then I can start with B or C. If I start with B, again I can start with A or I can start with B, right? I cannot start with B because I can only start with A and C. Okay, so if you see at any given position, okay, apart from the first position, rest all positions has 2 options available because I cannot choose the same character which was already chosen in the previous position. Okay, now that we have to find the kth happy string. Okay, so one option is to generate all the happy strings, okay, by trying to place each character at each position and try to generate all the happy strings using recursion and backtracking. You can generate all happy strings, or you can keep track of the number of happy strings so far you have generated, and the moment you have reached the kth happy string you can return. Okay, so that is what I have done. I've taken the second approach where I was counting the number of happy strings which were generated so far. The moment I've reached there, I am returning it. Okay, so the backtracking algorithm will basically look like, okay, we have 3 options. Okay, so what I have done is, if n is equal to 3, okay, instead of explicitly keeping track of whether I'm standing in the first position, only in the first position I have 3 options, in rest all of positions I have 2 options, right? Instead of explicitly keeping track of the first position, what I have done is, instead of generating a string of length 3, I was generating a string of length 4. Okay, n plus 1. Okay, and by default I have kept the first position as star. Okay, ash. Okay, let's say ash, or some other character other than ABC. Okay, now that I can only, irrespective of what position I am standing on, all I have to do, I have to keep a character which is not equal to its previous character. Okay, so I have 3 options over here, I have 2 options over here, I have 2 options over here. Okay, so I will be using a string, okay, and I will keep on adding the available character at a certain position, and I will ask recursion to generate the rest of the strings. Okay, I will ask recursion to populate the rest of the positions. Okay, the moment I have reached the end, okay, so I have kept A, and next let's say available characters are B and C. I will say I have kept B, and then the next available characters are A and C. I will keep A, and now that I have reached the end, okay, now that I have reached n plus 1, at this point, okay, I will take ABC as my string, because I have already appended hash in the beginning, so only this is my valid string. Okay, so the moment I have reached here, this is one valid happy string, correct? I will keep track of the number of happy strings I have formed. Okay, now once I have reached here, I will remove, I will backtrack, and I will remove A, and I will keep C. Okay, so this is again a valid string. Okay, now that I have generated for B, now I can keep C and I will keep A, so this is another valid happy string. Now I can again backtrack and I will keep B, and this is also valid happy string. So far I have excuse me, I have counted 4 valid happy strings, right? So this way we will keep on counting the happy strings, and the moment we reach K, we will be returning this particular string, which is from substring from 1 till all the way till the end. Okay, so let's look at the implementation. I just defined string kth happy string. Initially it will be null. The moment I have reached K, I will update this value. Okay, if it is not reached, then we will return an empty string. Okay, if K is null even after generating, then we will return empty string, or else we will return the kth happy string. And I've also defined few parameters at the class level, n, k, and count, where n is the given parameter, n and k are the same. I've set at the class level so that I can access in all my functions. And I've also defined a variable called count, which is initially 0, which will help me to keep track of the number of happy strings I have generated so far. Okay, now I have written a function generate, which will take an string and which will keep on appending the characters, okay, and generate the happy string. Okay, so as I mentioned, I will first start with hash as my initial position, and I will try to generate the append rest of the things. Okay, so the possible characters I have is basically A, B, C, right? And I should also keep track of what was my last character. Depending upon the last character I have, I have to choose one from these, right? So for each character in the space I have, which is ABC, if the last character is not equal to the current character in the space, then I will append it, and I will ask recursively to generate the rest of the string, and then once it is done, I will remove the character which I have appended. So this way I am backtracking in my recursion, and I am removing the characters which are added so far. Okay, so there will be a point where we will reach length equal to n plus 1. Okay, and at this point we will increment our counter. Okay, if the count is equal to k, that means I have to take the substring from first index till all the way till the end. That will be in my kth happy string, and then I will return it. Okay, if my kth happy string was already generated, I don't have to regenerate the rest of the string. So that is the check I have over here. Okay, so in the end, I will just call my generate function with this particular hash as my initial string, and then if kth happy string is already generated, I will return my kth happy string, or else I will return an empty string. Okay, if you submit this problem, all the test cases will be passed, and it is pretty efficient solution in terms of both time complexity as well as space complexity. I will also be posting the solution in multiple languages such as Java, Python, and JavaScript. If you are coming from any one of these languages, feel free to check the solution in the description. I will be providing the link. Okay, and I also want to tell you that I have also started a dynamic programming series where I was trying to solve all the problems in the study plan. Okay, I've already solved, so far I've solved 23 problems and uploaded the videos for all of them. Feel free to check it out if you're trying to brush up your dynamic programming skills, or if you want to understand how to solve dynamic programming problems. Okay, that's all about this video. Hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. Thank you.